Dr.S.Valliammai from Department of Chemistry, and I belong to Dr. MGR Educational and Research Institute. Now in this PowerPoint, I am going to explain about the kinetics, that is the unit 1 of Physical Chemistry 1. Now in this content, I am just going to explain the various order of the reactions, that is the first order reaction, second order reaction, third order reaction with the derivation of the rate constant and giving appropriate and suitable examples. Now first let us move on to first order reaction. So now what is meant by first order reaction? When the overall order of the reaction is 1, the reaction is said to be first order reaction. Now consider the reaction which is given below, that is A, that is the reactant, gives the product. Let the final concentration of the reactant be, let the initial concentration of the reactant be A, and after a time interval of T, let us assume that X concentration of the reactant has reacted and converted into product. The remaining concentration of the reactant will be A minus X. That is, A is the initial concentration and X is the amount which has been converted into product. So the remaining concentration will be A minus X. So now we all know that the rate of the reaction, that is dx by dt, it is directly proportional to A minus X the power 1. That is the equation 1. Now here dx by dt is equal to, now we are removing the proportionality sign and introducing a constant, and that constant is called as a rate constant. So now the equation 1 becomes dx by dt is equal to k into A minus x, where k is the rate constant. Now we are rearranging the equation 2. We get dx by A minus x is equal to k into dt. That is bringing all the like terms together. Now that is the equation 3. Now we are integrating the equation 3. So we get integration of dx by A minus x is equal to k is a constant. So we are just bringing out. So k into integration of dt. Now the integration of dx by A minus x comes as ln A minus x. So since there is a minus x inside, integration on that we get minus 1. So we get minus ln A minus x is equal to k, and the integration of dt is t. So kt plus c, where c is the integration constant. To find the value of the integration constant c, now we are substituting x is equal to 0 and t is equal to 0 in the equation 6. So now we get c is equal to minus ln A. So now we are substituting the value of the c in the equation 5. We get minus ln A minus x is equal to kt minus ln A. So now rearranging, bringing all the A terms together, we get ln A minus ln A minus x is equal to kt, that is the equation 7. So now we can write this A minus x as division. So we are writing it as ln A by A minus x is equal to kt, that is the equation 8. So now k is equal to, bringing the t towards the other side, we are getting 1 by t into ln A of A minus x. Now converting this ln into log, that is converting to natural logarithm, we just multiply the equation by 2.303. So now we get k is equal to 2.303 by t into log of a by a minus x. So this is the rate constant of the first order reaction. I am repeating, k is equal to 2.303 by t into log of a by a minus x. Now suitable examples are when ethyl chloride is decomposed as ethylene and HCl, and then two molecules of nitrogen pentoxide gets decomposed into nitrogen dioxide and oxygen. Now these two are the suitable examples for first order reaction. Now we are moving on to the second order reaction. So when the overall order of the reaction is 2, the reaction is said to be second order. Now consider the reaction given below, that is 2A gives product. Now as told previously, let the initial concentration of the reactant be A. After a time interval T, let us assume that X concentration of the reactant has reacted and converted into product. The remaining concentration of the reactant is A minus X. Now, the rate equation dx by dt is directly proportional to A minus x the whole square, since it is the second order. Now, to remove the proportionality sign, introduce the constant. So, the equation becomes dx by dt is equal to k into A minus x the whole square, where k is the rate constant. Now, rearranging the equation 2, that is bringing all the like terms together, we get dx by a minus x the whole square is equal to k into dt. Now on integrating this equation 3, we get integration of dx by a minus x the whole square is equal to k into integration of dt. Now the integration of that is 1 by a minus x square is nothing but it is the formula of 1 by x square. So now 1 by x square is nothing but it is x power minus 2. So x power minus 2 on integration gives you x power minus 2 plus n by minus 2 plus 1. So accordingly we get 1 by a minus x. So now the equation becomes 1 by a minus x is equal to kt plus c, where c is the integration constant. Now to find the value of the integration constant, substitute the value of x is equal to 0 and t is equal to 0 in the equation 5. So now hence we get c is equal to 1 by a. Now substituting the value c is equal to 1 by a in the equation 5, we get 1 by a minus x is equal to kt plus 1 by a. Now rearranging, we get as 1 by a minus x minus 1 by a is equal to k into t. Now k is equal to 1 by t into a minus x by a into a minus x. Now hence k is equal to 1 by t into x by a into a minus x. Again I am repeating, the rate constant of the second order reaction k is equal to 1 by t, bringing out the common a and t outside, so we get 1 by ta into x by a minus x. So now the very good examples of second order are, that is the ozone molecules. Two molecules of ozone molecule gets converted into oxygen, and the nitrogen monoxide, dinitrogen monoxide gets converted into nitrogen and oxygen. The third order reaction. When the overall order of the reaction is 3, the reaction is said to be third order reaction. Consider a reaction given below, that is 3A gives product. As told previously, Let the initial concentration of the reactant be A. After a time interval T, let us assume that X concentration of the reactant has reacted and converted into product. Now the remaining concentration of the reactant is A minus AX. Now the rate of the reaction dx by dt is directly proportional to A minus x the whole cube. Now removing proportionality sign, we are introducing a constant, hence the equation becomes dx by dt is equal to k into A minus x the whole cube. Now here k is the rate constant. Now on rearranging this equation, we get dx by A minus x the whole cube is equal to k into dt. On integration, that is integration of dx by A minus x the whole cube is equal to k into integration of dt. So now on integration we get 1 by 2 into A minus x the whole square is equal to kt plus c, where c is the integration constant. So to find the value of the integration constant c, we substitute x is equal to 0 and t is equal to 0 in equation 5. So hence we get the value of c as 1 by 2 into a square. Now substituting the value of the c in the equation 5, we get 1 by 2 into a minus x the whole square is equal to kt plus 1 by 2 a square. Now bringing all the like terms together, we get 1 by 2 into a minus x the whole square minus 1 by 2 into a square is equal to kt, or we can write as 1 by 2 into 1 by a minus x the whole square minus 1 by a square is equal to kt. Now bringing the t also to the other side, we get k is equal to 1 by 2t into 1 by a minus x the whole square minus 1 by a square. Again I repeat, the third order derivation is k is equal to 1 by 2t into 1 by a minus x the whole square minus 1 by a square. Now very good examples are sodium. When it reacts with bromine to form sodium bromide, it is a third order reaction. The same way, when nitrous oxide reacts with chlorine and form nitrous chloride, that is also a third order reaction. Now the certain questions are: derive the rate constant of the first order, second order and third order reaction. Thank you, students.